Hello everyone, welcome to another video. In this video, we will see some Linux troubleshooting scenarios. So in interviews, I'm talking about interviews for Linux administrators, system administrators, cloud admins, cloud engineers, sometimes DevOps engineers, and at times interviews for site reliability engineers as well. You will be asked about some troubleshooting that you've done in the past in your project. So I'm trying to include a few scenarios that you can explain at the time of interview that I was able to work on this type of issue. What did I do? What did I diagnose? All those things you can explain. So this video is going to help you talk about some troubleshooting that you've done in your project. So to perform all these scenarios, I'm using an AWS EC2 Ubuntu 24.04 LTS instance. You can use any VM, but I'm using AWS EC2 instance. And as you can see right now, I'm logged into the instance on my Mobaxterm terminal. So this is a fresh instance. I'm logging in for the first time. So if you want to follow along, you can use a fresh instance and you can perform all the steps that I'll be doing now. So just want to explain the scenario first. So what we are going to do here is I'm going to simulate some delay on the network interface of my Ubuntu instance. The interface name is ENS5, as you can check. You can type this command IP space A and you can see the name of the interface, your elastic network interface. It's called ENS5 basically. And so I'm going to simulate some delay on this interface. And then what I'm going to do, I'm going to ping google.com from this machine. So I'm going to be using outbound traffic basically. So from my machine to google.com. Okay, so let's see how much round trip time are we getting right now. So what I can do ping -c 5, which means that I want to ping google.com 5 times. So right now there's no delay on my machine. It's a fresh machine, and hopefully everything is working as expected. So if you just ping right now google.com, you can see I'm able to reach to this google.com server and I'm able to get the response back, and you can see this time. So this is actually called the round trip time. So round trip time means that from my machine to google.com and then the return traffic which is coming. So the amount of time taken by my machine or the traffic that is outgoing from my machine to google.com and coming back, it is just 7.5 millisecond, which is really less, which is really good. So which means that there are no issues right now on my machine on the network interface. So there's no delay. Okay. So now I will be using a command, this command. Let me explain this command to you before I run it. So the details are given here as well. So this command is going to intentionally make the network slower and more unreliable just to test. And I'm logged in as Ubuntu user, so I'm using sudo because I want to run this command as root user. TC stands for traffic control. It's a Linux tool used to control how network packets are sent and received. Then I'm using another utility called queuedisk, short for queuing discipline. This is going to decide how packets are queued, delayed, dropped, or reordered. Think of it as a traffic rule engine for network packets. Then I'm using add. Add means it's going to tell my Linux machine to add a new rule. So whatever rules are already there, do not do anything with it. Just add a new traffic rule basically is what I'm saying using this add property here. Then I'm saying dev ENS5, which means that I'm specifying my network interface named ENS5, and I'm just saying that apply the new rule, add the new rule only to the traffic on ENS5 interface. Okay, and then I'm saying root. Root means attach the rule at the root of the interface, which means that all the outgoing traffic on ENS5 is going to get impacted after I run this command. Then another uh, utility I'm using is netem, which means short for network emulator, used to simulate real world network problems for introducing delay, packet loss, some jitter, or packet corruption. You can use this netem utility. And then I'm saying delay 200 milliseconds, which means that add a 200 millisecond delay to every packet that is going to go out of this machine. Simulates slow network or long distance traffic. Example, far away servers or congested networks. And then at the end, I'm saying lost 10%, randomly drop 10% packets as well. Okay, so if you run this command and then just do ping multiple times, you will see 10% packet loss as well. So apart from the delay, you will also see some packet loss. Okay, basically, this is what this command is going to do. So you don't have to remember this command, but I just wanted to explain the meaning of all these different utilities that I'm using. This is just to simulate the delay, basically, because we have seen that right now our machine is working fine. I'm able to ping google.com without any delay. I'm getting healthy round trip times. As I mentioned, this is called round trip times. So after I run this command, we will see some increased round trip times. So I just ran the command, and now if I do ping again, you will see the amount of round trip times have increased. Okay, and I'm getting the response back slightly delayed. So the time that was 7.5 millisecond has now increased to 208 milliseconds. So we are able to ping google.com. That's fine, right? So there's no issue in reaching out to google.com, but there's a significant delay in getting the response back from google.com. So this is one of the issues that you will see a lot on production servers. Now we need to try to diagnose and identify the issue. One more thing you can see here is I sent 5 packets, but I only received 4. So 20% packet loss was also there. Okay, so I'll just clear the screen now. So what we're going to do is we're going to use a very good utility which is called trace route, which is to trace the route from your machine to the destination with all the hops included, which means that whenever you are sending any traffic from your machine to any other destination, you will always have some hops in between. Okay, so basically you do not reach to this destination directly. You have a lot of hops in between, a lot of intermediate destinations in between before you actually reach your final destination. Okay, so if you want to track where the delay is exactly, so you can use this trace route command. Okay, so let's just try to copy and see whether we are able to run the command. So I don't have this utility installed, so I have to install traceroute first, and I'm getting the option automatically. I've included here as well. Okay, so you can just run this command first to install this utility, and then we can run the traceroute command to get all the hops with their time that we are taking. Okay, I'm seeing this error as well, that unable to locate package inet utils traceroute. It basically means that right now in my package index, this package is not included. So I need to update the package index, which is to update your repository URLs basically. So you can do sudo apt update. It's going to update the package index from where I download all the packages. This is done. Now I can repeat that command. So now I'm able to download this package inetutils-traceroute. So this is done. So now I can try to run the traceroute command again. Traceroute google.com. So it is saying that it's going to trace the route to this destination google.com, and this is the IP address that it's able to fetch from google.com server on the DNS, and you can see that it can only go up to 64 hops at the at maximum. Okay, so we'll just wait for this command to complete. So this is the output of traceroute command. As you can see, traceroute google.com, and we are able to see the different hops before we were able to reach to our destination, which is 142.251.34.206. And you can see with each hop we are seeing some latency. This one. So here it is coming over 200 for each of these hops, but in real world you will see only few hops that is getting the delay, and that's going to be your pain point basically. So that's going to be your main hop that you have to investigate in deep. You have to find out who owns that particular hop, and you have to reach out to that team, or if you manage it yourself, then you have to look for that hop, why it's getting that delay. So that's how we use this traceroute command to identify the hop on which we are seeing the delay, and accordingly we need to troubleshoot that particular device which is getting the problem for us. So okay, so this is how you can explain the interview. Now, since I'm using AWS's VPC network here, inside VPC, AWS also blocks some of its traffic. Okay, so you see this star star star. It means that this particular hop was completely firewalled, or all the packets get filtered at this hop. Okay, so this star 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 means that we do not have access to this hop by default. So if I talk about these hops, so these will be generally AWS's internal VPC or net gateway addresses, some firewalls, or since I'm reaching out to google.com, so it can be some Google related public IPs as well, some regional data center which are not to be accessed by anyone by default. So this is how you can explain the network latency issues, that whenever we have this type of issue, users report to us or we get some report from the service desk, and then we have to start investigating. We can start with the ping command just to see the round trip times of that device which we are trying to reach from our machine, and then to diagnose and identify and troubleshoot the issue, we can start with the traceroute command, which is going to give us the information of all the hops that we are seeing from our source machine and between our destination machine. So we can see all the hops, and each hop we can check how much time is being taken by a machine to reach to that hop, and accordingly we can reach out to the owner of that device who manages that. So now to get rid of this, to get to the normal round trip times, you can run this command. It's going to delete that. Okay, so it's going to delete that delay that we introduced. Done. Now if I do ping-c ping-c5 google.com, I will see the normal round trip times as we were seeing earlier. Okay, and if I also do a traceroute, there also you will see. So now you can see 5 packets transmitted, 5 received, 0% packet loss, and round trip times are also back to normal. Now if I run the traceroute command, you can see the difference here as well. Okay, you will still have some firewall hops, as I mentioned. These are deliberately blocked by AWS, so we won't be able to access these. But apart from that, all the other hops we are able to see the normal round trip times, which means that the issue is resolved now. Okay, in this case, we resolved it via just removing that simulation. But in real world, you will have the hops to identify. You will be able to identify the hops which are getting the problems, and you have to reach out to the owner of that hop. That's how we resolve the issue. In production, we will have an emergency change management process in place, wherein we will raise emergency changes, we will get the relevant approvals, only then we'll be able to make any changes. So keep that in mind as well. So scenario number 2 is when one of our VMs become unresponsive, and we suspect that it is due to high CPU load on the VM. So now we have one more scenario here, wherein we have got reports from someone saying that one of the VMs has become unresponsive, and now it is our job to diagnose and troubleshoot the issue. So first thing is we need to simulate the issue. So I'm going to use the same AWS EC2 Ubuntu instance to increase the CPU load on that VM. Then we will run some diagnostic commands to identify the issue, and then we will see how we can troubleshoot, especially if you are working in a production environment. So first thing is I was just doing some testing. So here I have two terminals on that same VM, and on this first VM, first I need to install one utility. It's called stress utility. It's a way to simulate uh, to increase CPU utilization on a particular VM. You can install this utility and you can run a few stress commands to stress out your CPU on that VM. So first I need to install this utility. So I'm using Ubuntu instance, so I can use the apt command. So I'll do sudo apt install stress -y. It's already installed on my machine because I was just doing some testing using this stress utility. So it's installed. Here this command is for Amazon Linux AMI basically, but if you're using Amazon Linux, then you can use this command. Or if you're using any Red Hat based machine or CentOS or Fedora, then also you can use these commands to install a utility. If you're using Ubuntu, then you have to use apt command. So stress is installed. Now I'm going to use this command to stress out my CPU. So this is actually -- here, and here also it is --. So this command is going to stress out my CPU for 1000 seconds. And you can see that the command has attached to the terminal, so I won't be able to do anything for 1000 seconds on this terminal. So I have already logged into this VM on another terminal so that I can see whether our CPU utilization on this VM has increased or not. So here we can run a few diagnostic commands in Linux to check the CPU utilization. So I'm going to use these commands one after the other. First thing is I'm going to use the uptime command to check the load. So I can just copy this command. So you can see right now that load average is 1.29, 1.33, 0.99. So this basically means that the load average on my VM for the last 1 minute, last 5 minutes and last 15 minutes is these values. So if it is 1.29, it basically means that in the last 1 minute, more than one process is trying to consume a particular CPU. So when it's over 1, it is generally considered high. Similarly, in the last 5 minutes also, we can see it's 1.33, which basically means that in the last 5 minutes also, my CPU utilization or the load on this machine has been high because more than one process is trying to consume a particular CPU at a time. But in the last 5 minutes, it was nearly close to 1. So it is still on the higher side, but not as high as it has been in the last 1 minute and last 5 minutes. But anyways, this is actually considered high. Then next command I can check is top command. So after you run the top command, you can do Shift P, and it's going to sort out your output with the process that is consuming the highest CPU on your machine. It will come at the top. So you can see that the command that I ran on the other terminal, stress command, this is the command that is consuming 100% CPU on this machine right now. So my VM is currently stressed out because CPU utilization has gone to 100%. So this is one more way. Then if you want to use other commands as well, you can use htop, sort out by Shift P. So there also you can see close to 100% CPU utilization by the stress command. And similarly, there's another command, this one. So this command is going to list out all the processes on the machine, and it's going to sort the processes in a way that I'm only going to see the top 10 processes which are consuming highest CPU on this machine. So once again, I need to fix the command. It's --sort. So these are the 10 processes which are consuming the most CPU on my machine right now. And you can see at the top, you still have this stress appearing 99.9%. So these are the two processes that are making the system unresponsive because of high CPU utilization. Now, how to fix this issue? If you are working in dev and QA environment, dev QA or testing environment, you may very well kill the process straight away, because this is just a standalone process. It is not a service that we can restart at this point. So we generally, what we do, we try to kill the process and then restart it. So in dev, QA or the lower environments, you can do that very easily. But in production setup, you need to have some approvals in place. So generally, when you are working in a production environment and one critical VM is unresponsive, so what generally happens in most organizations, that you will have one high priority incident opened, HPI, in a ticketing tool. It can be any tool. It can be Jira or ServiceNow or some other tool. And you will have one incident management tool, basically critical incident management team, that is going to open a technical bridge call with all the stakeholders and the different technical teams coming onto the call to start to troubleshoot the issue, or identify, diagnose, and troubleshoot the issue. So in those cases, once you are able to identify that, in this case, it is just it is just one process that is consuming the entire CPU on this machine. So you recommend that killing the process and starting up again is going to fix the issue. So now after that, what happens generally, you will have one change process uh, as well in place. So for high priority incidents, you would call that emergency change management process, wherein you generally have one ECAB team. It's called Emergency Change Approval Board team, which is going to approve all the emergency change requests. So this is going to be an emergency change because you are working on a high priority incidents like a severity 1 or a severity 2, which has a very high impact on your business, on the customers. So you're going to raise an emergency change request, but this change request has to be approved by ECAB. Also, if it is related to an application, if this particular process is related to an application, then you would also want the application owner's approval as well. So now just assume that this is the production server where you have identified the issue, and now you need to troubleshoot it. And you have already raised the emergency CR. It has been approved by the ECAB and your application owner. The next thing is you can go ahead and kill the process. Okay, so what we will do, we will use the kill command, kill, and we won't use any flag here, because with kill we can use a certain flags if we want to, but in my case I'm going to use a kill without any options, which basically means that I want to gracefully kill this process. Kill and then the process ID. So process ID, we can see stress command, it is using 2440. So I can copy this, I can paste it, hit enter, and if I repeat the command, I won't see this again because the process has been killed. And I can see on the terminal also the process was killed. And now if I do top, then sort it out with shift P, you can see the process is gone. And now we have all the processes are consuming normal CPU, and the load average is also decreasing right now. As you can see, it's on the decrease, and after a few minutes you will see it will go back to normal levels. Okay, so this is how we can fix a particular issue in production. Okay, you can see the load average is decreasing gradually. Okay, so this is how you can fix this type of issue. Then scenario number 3, disk space full. So once again, this is a very common issue where the disk space is full on the machine, and you need to either free up the space, or if you cannot, then you have to add some additional storage. So let's check the disk utilization right now on my VM. So I'm using this df space -h command, which is for checking the free disk space on the file systems. And as you can see, the total size is 6.8 gigs on my root file system /dev/root. out of which only 2.1 gigs has been used and available is 4.7 gigs. So only 31% is in use. So right now the machine is fine. There are no storage issues, but I'm going to create one directory under /tmp directory. I'm going to create another directory called bloat because I'm going to bloat the server, and then I'm going to use this disk destroyer command. So this is a standard command which you can use to increase the, or you can use to create a file that is going to consume all the storage on your machine. So this is called disk destroyer command, and here I'm just specifying few options that I can use to create a file that's going to consume all the space. So the command is ran, and now after some time you will see that the entire storage on this machine is being consumed by this file that I'm going to create. Okay, so the file name is going to be under that /tmp/bloat directory. Name of the file is going to be a big file, and it's taking some time, but it's going to do its job. So it's going to consume all the storage on my VM. So you can check it with this command again, df space -h. You can also use t to specify the type of file system. So t is optional, you can remove it as well. So you can see that right now the storage which was only 31% used, now it's 100% used because all the storage is being used by this big file in the /tmp/bloat directory. So no space left on the device. Okay, so this is done. Now how to identify and diagnose the issue? So you can use this command. This command is going to what it's going to do, it's going to check the disk usage of all the files under my root directory, which is /. So /* means under / I want to check, I want to go through all the files and directories, and I want to sort this out so that I'm able to see the file or directory which is consuming the highest storage. And then if I see any errors, that those errors will be redirected to /dev/null. So if you run this command, you will see sort-h is going to sort out the output, that you will see the file with the highest storage consumption at the bottom of the output. So now you can see that /tmp is consuming 4.7 gigs, and /tmp, we know that we only keep the temporary files. So temporary files is consuming the highest storage on the device, which is not a good thing, which is not the right, or which is not the ideal scenario. So now what we can do is, now we have like multiple fixes here. For example, that this file is in /tmp, so we know that it's a temporary file. So in this case, we can just delete the file directly. Or if the file is pretty important to us, we cannot delete it, then we can extend the file system as well. So I'm going to show you this scenario, fix number 1, where we will delete the file /rm-rf/tmp /bloat and big file. So now if I repeat the command, we can see that /tmp has only 48 kilobytes of storage used. So in this case, I just removed the file because I already knew this file. What you can also do is, let me repeat the command to create that file again, this one. So what I'm just showing you, that I simply deleted the file under /tmp because I already knew the name of the file, /tmp/board/big file. But in case you want to identify exactly which file is actually consuming all the storage, you can run the same command under a specified directory. So now we ran the directory under / the root directory, but we can repeat the command, and this time we can specify under /tmp. So now I'll repeat that command again, and we can see that slash tmp is consuming all the storage, but we want to see which file or directory is consuming the storage within slash tmp. So I can repeat the command, and this time I can specify slash tmp slash star. So it's going to show me all the files under slash tmp. As you can see, slash tmp slash bloat. Now I want to see, first of all, I want to see whether slash bloat is a directory or a file. So I can do ll long list on slash tmp, and I can see that bloat is a directory. So maybe within the directory there is some file which is consuming all the storage. So I can repeat the same command, and this time it's going to be slash tmp slash bloat slash star. So now I can see there's only one file or directory. It can be a file, it can be a directory, which is consuming 4.7 gigs. So I will again do ll on slash tmp slash bloat, and this time I'll do big file. And you can see now I know that big file is just a file. Okay, it is just a file which is consuming all the storage. So now I know which file to delete or get rid of. Okay, so now I can again repeat the command to delete this file. rm-rf. This is done. Now if I check the storage, I can see the storage is now back to 31%. So this is like one more, this is like one way. This is fix number one, where we can simply delete the file. In case we cannot delete the file, we are going to extend the file system. So I'm going to show you this scenario also. So option number two for this issue, that we can extend the file system as well. Since I'm using AWS EC2 instance, I can follow the standard guidelines and instructions given on its official documentation page. So let me recreate the issue. So let me just create the file again. So it's done. In my last company, I used to extend the file system size a lot. Now it will depend what size you want to add to your volume. So in my last company, I used to add volumes as large as 1000 gigs also. Okay, and to be able to do that, I sometimes need approval also from my client infrastructure manager. Okay, so it will depend on where you're working. If you have a process wherein you need to take an approval, because if you are adding like 1000 GB of storage to the VM, it's going to incur some really good costs. So in those cases, you may have to reach out to your manager or someone who has the authority to approve this type of request to add additional storage to a particular VM. So you can follow this official documentation given by AWS. And one thing we need to do is we need to find out the file system type also. So for type, I'm using this capital T option here with -h. So this command means field disk statistics of your file system. It should be in human readable format, and T stands for file system type. As you can see this one. So the main file system that we are trying to extend is /dev/root, which is ext4 type of file system. So depending on this file system type, the commands are slightly different. So it is important to understand what type of file system you want to extend right now. Okay, so now you can see here all the instructions are given. You can follow this Linux instances. I'm using Ubuntu, which is a Linux instance. So the first thing is we will see what all block devices are attached to our machine. So we can run this command sudo ls blk, which basically means that list block devices. So there's only one block device, which is NVMe0N1. The size of it is 8 gigs, and this block device is partitioned into various parts. You can see. So you can see this P1, P14, P15, P16. So we have 4 partitions of the same block device right now. And the one that is in question, or the one that is being used, is NVMe0N1P1, because the size of it is 7 gigs. Okay, as you can see, this one 6.8 gigs. So this is the one that we are that we want to extend, and it is mounted on root directory. This is mounted on root directory. So this is the file system that we want to extend. Okay, so what we're going to do is, the first thing is we need to extend the file system from AWS's end. Okay, that means either you can do it from the CLI or you can do it from the console. So I'm going to show you how you can extend the size of an existing EBS volume from AWS management console or the user interface. So I'm going to log in to my AWS management console here. This is the instance, and you can go to storage. You can open this volume in a new tab, and you just need to select the volume, go to actions, modify volume, and you can add the additional storage. For me, I'm just adding 2 gigs. Sorry. So from 8, I need to make it 10 and modify. Okay, you will see this type of warning. You can go through it, but I already know what it's going to do, so I'm just going to hit modify. So this is going to increase the volume of this block device, of this EBS volume, basically from 8 gigs. If I hit refresh, you will see it has increased to 10 gigs. Now back to my machine where I'm logged in, where I'm SSH'd into the machine. If I repeat this sudo ls blk command, I will see the size of my block device volume has now changed from 8 gigs to 10 gigs. So this is done, but in Linux, whenever we are extending the file system from the UI, that is not enough to make it usable. So you have to run some additional commands from inside of the operating system so that you are able to use that additional space. So the size of the block device has increased, but if you see the size of the file system, or you can say the size of the partition of your block device which was in question, it is still 7 gigs only. So we need to increase the size of the partition also. So this is where you have to follow the commands given on the AWS's official documentation. So I'm using NVMe0N1 NVMe0N1 type of block device, so I can use this command. You just need to copy this. I'm going to explain this command. So what I'm saying is grow my partition. So this is my partition. It is only of 7 gigs. So I need to grow this partition, and this partition is part of which block device? /dev/NVMe0N1. So here you will see NVMe0N1, but when you're using this command, you have to specify the device location, the exact device location. So these block devices are always under /dev. So it has to be /dev/name of your block device space, then the partition that you want to extend. So this P1 stands for partition 1. Okay, so for that we will just say 1 here. If you are extending partition number 14, then it will be 14. Similarly for 15, it will be 15, and for 16, it will be 16. In my case, this is NVMe0N1 P1, which means that partition 1 is what I want to grow. So this is what you do. You run the command. Okay, there was some temporary error, so I repeated the command and I was able to extend the partition. Okay, you will see this type of message, which means that the command ran successfully. To verify, you can again check the command sudo ls blk, and you will see now the size of the file system was also extended to 9 gigs from 7 gigs, because we added two additional gigs to our block device size, right? So NVMe0N1 P1 has now increased from 7 gigs to 9 gigs. Okay, but our ultimate aim was to increase the size of the file system, which is still at 6.7 gigs. It's still 100%. So there are 3 steps involved. First, you will extend the size of the file system either from the AWS management console on your EBS volume, or from CLI, or some other automation script if you are using. Then you have to extend the size of the partition on which your file system is mounted. My file system /dev/root is mounted on root directory, and this root directory is part of partition number 1 NVMe0N1 P1. So this is the command that I will be running to to extend the size of the partition. After that, last step is to extend the size of the file system itself. So this is how you extend the size of the volume in Linux. Okay, so you have to perform 3 steps to make that additional storage that you have added to your volume, to make it usable. Uh, you need to perform these 3 steps in sequence. So now if you just extend a little bit further, you will see 2 commands. So you see this command xfs underscore growfs hyphen d slash. So if you are using xfs type of file system, then you can use this command. If you are using ext4, okay, it's given here clearly that if you're using xfs file system, use this command to extend the size of your file system. If you're using ext4, then use this command. So as we have seen that we are using ext4 type of file system, so this is the command that we have to use. So I can copy this command. Let me clear the screen once. So this is what we have to use: sudo resize to fs. Fs stands for file system. So I'm trying to resize my file system. My file system is on /dev/nvme0n1p1. So this is only for ext4 type of file system. You can use this. So this is the type of message that you will receive. So let's see. And you can see the size of the file system now has been increased from 7 gigs to 9 gigs. Earlier it was close to 7 gigs. Now it's close to 9 gigs, and used is 6.8 gigs, as it was earlier also close to 6.7 gigs. But use percent has now gone to 78%. So this is how we were able to extend the size of the file system without deleting any files or directories to make storage free on our machine. Okay, so this was fix number 2. Fix number 2, we can try to extend the size of the file system given we have all the relevant approvals in place. Now I will talk about fix number 3. So one more thing you can do is you can also compress the files. So whatever files are already there on the device, on the VM, if you do not have the option to delete it, or you do not have the option to extend the file system, you can also compress the files. You can use various compressing utilities like gzip, which is one of the most common way to compress some files to free up some space on the machine. So you can try that option as well. Okay, so apart from these 3 options, there's one more. You can say it's type of a sub option related to the same issue that I want to cover as well. So issue is the same, that our root file system is full, and I want to just cover some real world context where you were where you're going to perform all the steps that I'm going to talk about now. So one of your VMs that is hosting one of your critical applications, on that VM your root file system is full right now, and this has taken down your payment systems. Okay, or it can be logging pipelines, or maybe you have a CI server which is clogged right now because of this issue. Okay, so and in your investigation, in your diagnosis, you found that this file system, it got full because of logs. Okay, because if you are working for a big organization like Netflix, for example, okay, there will be logs that will be generated on the VMs where you have some application hosted. Okay, so the logs are going to grow silently, and one day the server is going to stop responding. So this is the exact scenario, that we have a VM which is hosting our critical application, but at the same time there are some logs that get generated, and the log size has grown so large that it has clogged our file system, and entire storage is full. Okay, especially I'm talking about the root file system. It is full right now because of logs that have grown a lot in the last few days. So this is the issue. So I'm going to simulate this issue now. So it is kind of similar, that I'm going to create a big file which is going to occupy some space, but just assume that this is a log file. So what I'm going to do is let's go to our VM again, and we have some free space now, 78%. I'll try to occupy the space again. So this is the command I'm going to use. It's going to create a temporary file, and the size of the file that I want is, let's keep it to 2 gigs. Okay, because we just have free, we just have 2 gigs of free space available, as you can see available. So let's keep it to 2 gigs. So it's done. Now if I do, you can see again the root file system is 100% full. So this is the exact scenario that we've already seen. We have seen 3 options. Now we are going to see another option that we can do. So I'm using this -r option. -r means reverse order. So if you remember earlier on that when I was using this sort command, I did not use -r. So I was getting the folder or the directory where the storage was consumed the most at the last. But now I'm using -r to reverse the order. So now I'll see everything on the top basically. So under /temp directory, I have this file called, under /temp, I have 5 gigs of space. But I also have another file that I just created, and it was under /var/log, as you can see. So it is consuming 2.3 gigs. And this is what we want to target right now. So we know that under /var we have log files. So I have a log file actually, which is consuming 2 gigs of space. Okay. And what I need to do here is this log file I cannot delete because it needs to capture some critical logs also. But whatever log files, or whatever log data we have in this log file, we can clear that up. I'm going to clear the contents of this file so that the file itself is going to remain on the device, and it's going to keep capturing all the future logs. But whatever the current log data that we have stored in this big file.log file, I'm going to clear this file. So I'm going to reduce the size of the file from 2.3 gigs to 0 so that it is able to capture all the new logs, but all the older logs which I don't need right now are cleared up. So this is one of the other options that you can do apart from all the 3 options that we spoke. So what I'm going to do is I'm going to use this command. It's going to truncate the file. So a truncate means that I'm going to clear the contents of this file so that the size of the file reduces to 0 bytes. One more thing I want to show you is, let me repeat the earlier command, and we can go under /var/log/star. Okay, so because I want to target this file, big file.log file, so I'm going inside /var/log directory. So now you can see the size of the file is 2 gigs, var log big file. So now I'm going to run this command to truncate the contents of this file. Now if I repeat the command, you will see the size of the file has reduced to 0, this one. Okay, so the size of the file is reduced to 0. So now we have some free space again available. So the root file system has again gone back from 100 to 78%. So we have 2 gigs of space available because 2 gigs of space was being captured by var log big file.log file. And after truncating the contents, I was able to get the size of this file to 0. So the file itself remains on the machine so that it can capture all the future logs, but all the content of the file was deleted. So this is one more option that you can try when your root file system is full. And one more thing I want to cover here is, so that you don't see this type of issue where the log file is getting full and then you are manually checking the issue and you're truncating the contents of the log file, it is better to enable log rotation. So this is like a production fix that you can enable log rotation using this file. It's called /etc/logrotate.conf. Here you can see all the default log rotate configuration. So you can use it to auto rotate your logs. Okay, so it's going to clear up your log file from time to time. So this is one of the production fixes, and this is what we should use if we are using these type of VMs where we see that the log file size increases a lot in a small amount of time. You have the option to enable log rotation so that the log file size is getting reduced from time to time and you are able to have the free space available. Unable to SSH to Linux servers. In my case, I'm using AWS EC2 Ubuntu instances. So This is a very common issue that sometimes appear. If you see in the screenshot that the permissions on the key, on the private key that you are using to authenticate to your EC2 instances is not properly set. So this is the error that you're going to see, bad permissions. So I'm going to replicate the issue first, and then we will see how to troubleshoot it. So let me head over to my AWS management console. So I have two instances here. I have a Bastion host. So this is going to be my main server that I use to access all my other important application servers. So I'm already logged into my Bastion host. You can see its IP address ending with 44.79. So I'm already logged into this. And from here, I'm going to log into my application server. So I can click on the instance ID. I can click on connect. I can copy the example command. And I have already copied this mykp.pem file. So this mykp.pem file is already available on this Bastion host, so that I can authenticate to this instance. So let's try to see whether we are able to log in or not. So as expected, the permissions that was set on this file were not proper, so it is not letting me authenticate using the key pair file. As you can see, warning, unprotected private key file. The permissions are 0777, which is not ideal, and AWS does not allow you to log in to any instance with these permissions on the private key. So what we have to do is, what AWS suggests is that the permissions on the private key should be 400. So we can do chmod 400 and then the name of the key file. So 400 just means that the private key file should only be readable by the user owner of the file. So let me just show you the permissions first. So you can see right now it is set to RWX, 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 which means that 777. So Ubuntu is the owner and Ubuntu is the group owner as well. I'm logged in as Ubuntu user here as well. So what we have to do is we have to change the permission to 400 so that only Ubuntu, who's the user owner, is able to read the file, and everyone else, I'm talking about the group permissions and other permissions, it should be set to 0. So now let's check the permissions again, and the permissions are set correctly now. You can see it is only readable by Ubuntu user. Okay, so this is the name of the group. So this group also do not have access to this key file, and others also do not have any access, as you can see. So only user, which is Ubuntu, has read access to this file. Now we can try to log in again. And this time it's going to let me in, as you can see. So I'm able to log in now after I set the right permissions on my key file. High CPU usage by a Java application slowness. So what we're going to do, we are going to create a sample Java application, and then we will configure it so that it is trying to consume a lot of CPU on our VM, and then we will see how we can investigate and how we can troubleshoot the issue. So in this case, the Java service is going to run as a daemon, and it's going to be managed via systemctl, and it will intentionally spike the CPU for us so that we are able to see that slowness, diagnose, and then investigate and troubleshoot. So real world context, this can happen when you're using Java application. It can happen when there are some regex bugs, infinite loops, misconfigured Java applications. So these are some of the scenarios wherein you will see your application is going to intentionally spike the CPU usage on the VM. So how to simulate this issue? We'll try our best to create a production-like Java application, which is going to include a CPU bug. Application is going to behave. It's going to run continuously like a backend service as a daemon. It is not going to expose any UI. It's going to be a headless daemon service. It will contain a CPU bug. It's going to be a loop basically, which is going to consume CPU on our machine. and it's going to log periodically so that it looks alive. Okay, so these are some of the things that we are going to configure so that we are able to see a real world Java application consuming CPU on a VM. So let's follow this step by step. So I'm logged into my application server. So the application server, and I'm going to create one directory here. Let's do that. Okay, to become root. So I'm going to cd into this slash ops slash high cpu hyphen app folder, and I'm going to get a file high cpu service.java, and I'm going to paste this code here. So this is an application that's going to consume CPU. You can see it is using a loop basically. So it's going to be a Java process that will continually run in a loop, and it's going to consume CPU on our machine. So we have introduced a CPU bug. So let me just save and quit. So okay, I need to become root. So sudo is done. So this is how it's going to look like. So it's a Java application, so we have to install few Java related packages on the machine so that we can run this Java application. So I'm going to install this OpenJDK 17. So it's going to install this Java package. So there are two packages, as you can see, OpenJDK 17 JRE and OpenJDK 17 JDK. So I'm going to install both. Okay, there is some issue, so let me do sudo apt update first to update the package index. Now I will try to repeat that command, and this time it's able to find the package and install it. Earlier it wasn't working because that the package wasn't added to the package index. It wasn't able to find that. After updating the package index using apt update command, it was able to find the package and install it on my machine. So I've just installed this first package. Now I'm going to install the other one. This is done. To compile a Java application, we will use the standard Java CLI commands. So it's Java C, then the name of the file that I have created. As you can see, name of the file is high cpu service.java. So you run this command. It's going to compile this Java application. Okay, I think the file has some invalid characters. So let me open the file again. Okay, what I'm going to do here is I'm going to use ChatGPT just to format this. Okay, so we can copy it from here, and then I'll go back to my terminal. I need to open this file as root, else I will get the permission issue. So delete everything. And now I will try to recompile. So this time it worked well. And after I run this, you will see there's another file which is created, which is high cpu service.class. So this was created after I compiled the Java application. Okay, so far so good. Now head back to your documentation again. So this step is done. Now I'm going to create a runnable jar. So I'm going to copy this. So these are all Java related steps. You don't have to worry too much about it. I'm just trying to replicate, I'm just trying to simulate the issue that we want, so that we can diagnose and troubleshoot the issue. Okay. Okay, it's done. So I've created the jar as well. As you can see, hi cpu-service.jar. So this is going to be a main executable to start our Java application. So you can do Java space -jar and then the name of the jar file. So the service has started now. So as I mentioned, after creating, compiling, and getting the jar file, starting the application, I'm going to run it as a daemon, which means that it's going to continuously run in the background. So for that, I'm going to perform some additional steps. In the terminal, I'll go to my AWS Management Console, and I'm going to copy this. Login command, and I'm going to open this machine in one more terminal, and I'm going to head back to the same directory. So I'm going to do sudo cd/opt cpu app. So I'm inside this directory here. So we'll be creating this service to run in the background as a daemon. So for that, I'm going to create a file. So I'm going to run it as a systemd service basically. So let's get this new file and copy this content. Save and quit, and then reload the systemd. So run these commands. It's going to apply the changes. You can enable the service just like you do in real production setup. So you can enable it. The name of the service is hi CPU. It's done. And then we can start the service. So it's going to start our service to run in the background as a daemon. You can check the status as well. So you can see it's running 6 seconds ago. So the service that we just compiled using Java code, using Java code and Java application packages, now it is running as a daemon. Okay, so this is a custom systemd service which we can manage using systemctl command line tool. And this is here you can see the service is running. It's in active running status. Okay, now we will observe the CPU utilization on our machine after this service is running. So let's use top command, sort it out with CPU, shift P, and you can see this Java application is already consuming 100% CPU on our machine. The top command shows that the CPU utilization is already 100%. So Java process at high CPU. App is running, application is running. We just checked. We can check again. It is running, but it is running. It is taking a lot of resources on our machine, which is not ideal. Okay, so there's one more command that we can use to see the process that is consuming the most CPU. So I'm going to copy this, come back here, clear the screen, and okay, I need to make correction to this command. It's hyphen sort. So you can see it's the Java high CPU service that is consuming 99.5% CPU on our machine right now. We can also check the live logs also. So we can use this generalctl utility to see live logs for any service. This is our customized service, but it can be for any service. So these are the live logs. No problem. I'll just come out of it. the first thing that we can do is we can restart the service. Okay, so we will just try to restart the service. So I can do systemctl restart high CPU. I need to be root to do that. So the service was restarted. Now if I check the logs again, we will see that the service was restarted. Okay, so now I can see some additional logs that the service stopped and then it started again. Okay, so live logging is working well. Now we can check the status again. So this service is again in active running status. You can see it was restarted 23 seconds ago. And now if I check the CPU utilization of processes, so again it is consuming 99.6%. So what we did, we just tried to restart the service once just to see whether it's going to fix the issue for us or not. But it is not fixing the issue. So we need to see what else we can do to remediate the issue at this point. So the service is running, Java is burning our CPU, and this time restarting alone won't fix it permanently because the bug is in the code. Okay, so why the service restart did not work? Because there's some code related issue in the Java application. Okay, and that part need to fix. So I'm going to open this Java code again. So we need to fix the bug that we introduced. So this is the fix that we are trying to apply now to our Java application. So this is the fixed code. And here what we are trying to introduce here is, you can see this fix throttle CPU thread.sleep 50. It means that we are trying to introduce a slight pause to this active Java process. So the pause is going to be of 50 millisecond, which is going to drastically reduce the CPU utilization of this process. So it's going to fix the issue for us. Okay, so as I mentioned, this is a Java code related issue. So the restart of the service did not help. So I'm going to keep everything same. Only thing I'm going to change is, or maybe we can just copy and paste the entire code as it is, the fixed code. So I can just copy it from here. And I'm going to copy and I'm going to go back to my chat GPT. So this is the code that we can copy and paste. So copy, come back to the terminal, delete everything, and paste the fix code. So this is the fix that we've introduced. It's done. Now we need to rebuild the jar as well because we've changed the application code. So we can run this. Just add a sudo to every command if you are using the standard user here. So Java application was recompiled, and I'm going to create another jar. So I'm going to do sudo this command, and then I'm going to restart the service. Restarted, the service has been restarted. Now I can check the status of the service first. The service is active running 10 seconds ago, and we can check now whether it is consuming the CPU. Now let's check the top command. Start it out with Shift P, and you can see now the Java application is only consuming 0.3 or maybe less than that. So it is back to normal after we were able to fix the Java code. So it was a code configuration issue. The code wasn't set up correctly. So after we were able to fix the code, we were able to get the application to consume a normal CPU instead of 100% CPU as it was doing earlier. Okay, so this is how we were able to fix the issue. So expected result is Java uses 1 to 5% CPU. As we've seen, it is below 1 actually in our case, and load average is going to drop as well. As you can see, load average right at the top. So it's nearly zero, because this was the only application that was running and it is not consuming much at the moment. So in the last 1 minute, last 5 minutes, and last 15 minutes, so the load average seems to be normal. The system is stable and incident has been resolved correctly. Another important issue that you will find a lot in production, that is high memory usage, out of memory kill. So real world context, if you have some containers running, or you have, once again, you have Java applications that you are running on a virtual machine, it's causing frequent OOM errors, out of memory errors. It is consuming too much memory on your VM, so the Java application is going to run into OOM kill errors. So we'll see how we can simulate this, and then we will see how to diagnose and troubleshoot the issue as well. So I'm on my machine right now. So we've already installed this. We can just check the Java version. So it's running 17.0.18 Java version. So it's already installed, so we do not have to repeat these. Now I'm going to create another application. It's going to be Java out of memory application. This app is going to keep allocating memory and never release it, which is going to consume too much memory on my machine, and it's going to end up with OOM errors. So I'm going to run this command. So let's go to home directory once and let's create this. Let's go inside this folder, OOM app, and let's create another file, oomservice.java. And this is how it's going to look like. So you can copy this code from here again, and I'm going to format it once again. So I can just type please format. So let's copy this code, paste it here, save and quit. Once again, we don't have to think too much about what the code is actually doing. It is the job of developers, but I'm just trying to simulate this issue so that we are able to analyze and troubleshoot this out of memory issue by a Java application. It's done now. So once again, I'm going to compile this application. It's done. Next is I'm going to create another systemd based service so that it runs in the background as a daemon, and then we will see how it behaves. So I'm going to create another systemd service. Use sudo with all these commands if you are not running as root user, because it's going to need root user privileges. I can copy this entire thing as it is. So just ensure that you're using the right working directory. I'm logged in as Ubuntu user, and I created this directory under the home directory of Ubuntu user. So this is what the path is going to look like for me. If you are following along the same way, then you can use this, or if you're using any other directory of your choice, then you have to change the working directory in your case. Done. Okay, I think I did not copy everything. So OOM service, this also I need to add. Next I'm going to start the service. So once again I need to reload the daemon, and I'm going to enable the service. The name of the service is going to be OOM-app, and I'm going to start the application. Check the status of the service first. Okay, it's failing. Let's see why it's failing. Okay, so as you can see that the flags that I passed, it's already working and I wasn't able to start the service. The service has failed you with OOM kill error as I mentioned. So this is what we expected, that the application is not going to work. It's going to fail with OOM kill errors. So that's what is happening right now. Within seconds to minutes, as I mentioned, it depends on what kind of machine you're using. So for me, it just happened almost instantly that I was able to get this error OM kill uh, almost instantly. So it just failed. It just did not take that much long. So we can just verify a few things as well. So we can use this dmessage logs, multiple ways to find out the errors that you're seeing with your service. So I'm seeing this OM error everywhere. So this is for this OM app dot service only. As you can see, OM kill error is saying out of memory, memory C group out of memory killed process. So the kernel is going to kill the process whenever it is trying to consume too much memory on my VM. So that's what the behavior is. Then you can also check whether you are able to, get the information from the Linux control groups. So you can just try to cat the contents of this file. Let me clear the screen. So you can see OM kill error 2. So twice this error has occurred, and it has been captured by our control group as well. And then we can see the standard general CTL command as well. So there also you will see these errors. Okay, out of memory, you can see. So why did we get OM killed here? The application kept allocating more memory than the limit set by the operating system for that service. When it crossed that limit, Linux forcefully killed the process to protect the system from running out of memory. So this is the expected behavior of our Linux kernel. Okay, so in the interview also you can code this case that we were working on some Java applications which were consuming too much memory, and we saw a lot of OM kill errors. So this happens when the application is trying to allocate more memory than the limit which is set by our operating system for that service. So when it across that limit, Linux forcefully killed the process to protect the system from running out of memory. Now, how to fix this issue, especially if you are working on a production application? So you can put a hard limit on your memory boundary on this Java application. So you need to make sure that Java knows how much exactly your uh, application needs to use the memory on the machine. So you can do that. So what we can do is we are going to update our service file to apply this fix to put a hard memory limit on a Java application. So I'm going to open the file again. So let me open that systemd service file, this one. And as you can see here, what I'm going to update is, so I'm going to pass this 128 XMS 128M 128M here, and XMX 256M. And here also I'm going to specify maximum directory size is going to be 128M. So it's going to be 128M. And memory max, I'm going to keep it as let it be 300M only, and restart I'm going to set it to always. So these are some of the configuration changes that I'm doing on my Java application, so that it is able to work properly and it is not killed by the Linux kernel. Everything else is same, so just save and quit, and then we need to run those commands again to reload the daemon and everything. So let's do that. Let's restart the service also, and let's check the status. So now you can see the application is running. Okay, it's failing again. It came up for a while and then it failed again. Okay, maybe because I have another service. Let's see this. How much memory do we have available? So we have 347. Let's do one thing. Let's just stop the other service. So systemctl stop. I have this CPU intensive application also running, so I'm going to stop that. We'll stop. Let's restart this service. Let's check the status now. So you can see it's active running now. Okay, so this is just like you are just tweaking some of its parameters so that it is able to fit in the VM that you're using. Because I'm using T3.micro instance, it does not have that much memory and CPU available. So we need to have this application consume very less memory, only then it's going to stay alive, else it's going to be killed. This issue was related to application configuration again. And in these cases, what happens, we need to reach out to the application team that this is a application configuration issue, and you need to set the configuration on the instance. You need to set the parameters of your application correctly so that it is able to run on this particular instance, or else we need to increase the instance size. In most cases, the application configuration has to be corrected, because we don't want to spend too much resources on a very simple application. So this is a very simple application which is not doing much. So ideally it should not consume too much memory on this VM. So we need to tweak a few values so that we are able to fix it permanently. Okay, so these are some of the troubleshooting that you can quote in your interview whenever you are appearing. And if someone is asking what kind of troubleshooting have you done, so these are some of the things that you can quote in the interview. Okay, so as I mentioned, I tried my best to replicate these issues as it is done in production. And I also spoke about how to deal with these issues if you are working on a production server. In production, you will always have some emergency change management process. Okay, you have to follow that. You cannot just make changes just like that on the production server. So you will have to follow that emergency change management process. I hope this video was useful to you. If you like this video, then there are other videos and playlists on my channel that you can explore. Like I have Linux for DevOps course, I have Docker for DevOps, I have AWS for DevOps. I also have DevOps and AWS real world projects. I also have a CI/CD pipeline project. I also have a Terraform projects and a lot of content on site reliability engineering, like interview question and answers and other useful stuff that can help you crack any DevOps SRE related interviews. So do check the content on my channel. I'm going to paste the URLs of some of the important playlists in the description of this video as well. All right, that's all for this one, and I'm going to see you in the next one. Bye for now.